All right, let's build another confidence interval, and we are going to be looking at Emily here. For a science fair project, Emily conducted an experiment in which she tested professional touch therapists to see if they could sense her energy field. She flipped a coin to select either her right hand or her left hand, and then she asked the therapists to identify the selected hand by placing their hand just under Emily's hand without seeing it and without touching it. Among 331 trials, the touch therapists were correct 151 times. So the purpose of this is to test the hypothesis that the touch therapists can use energy fields to sense which hand was selected by the coin. Okay, so let's look at the first question. Given that Emily used a coin toss to select either her right hand or her left hand, what proportion of correct responses would be expected if the touch therapists made random guesses? So if they were just randomly guessing, now you might say that this is kind of a silly example, but there are examples of people who have claimed to have been able to sense metal and things like that. And so that's kind of where this question is created from. But in any case, if the touch therapist was just guessing which hand she was using, we would expect that they would be correct 50% of the time, because they're just guessing which hand the coin is under. And so they would actually get it right just by pure luck 50% of the time, give or take. So that's going to be important because you remember I talked about 50% in the previous example. So the idea is we're going to construct a confidence interval from these numbers. If the entire confidence interval is above 50%, then that would suggest that there's evidence that the touch therapist can sense energy fields. But if the confidence interval contains 50%, then that means they could just as easily have been guessing than if they had been sensing the energy fields. Okay, so using the sample results, what is the best point estimate? Okay, let's go back through and see what we did. 331 trials, that's going to be our sample. So n is equal to 331. She was correct, the therapists, were correct 151 times. So that means that p hat is going to equal 151 divided by 331. And if I grab my calculator, 151 divided by 331 is equal to 0.456, which is the correct answer. I'm going to start using more decimals because I think I want to be exactly right. So if we round that to 3 decimal places, the answer would just be 0.456 is our best point estimate. Not looking good for the therapists, actually. They appear to be less accurate. Using Emily's sample results, let's construct a 95% confidence interval. Okay, we've already got the formula for that. So let's find out Q hat, and let's find out Z alpha over 2. So Q hat is just going to be 1 minus this number. So on my calculator, I can go 1 minus this number, and that will go ahead and give me Q hat. So Q hat is going to be 0.5438. I'll just stop there. And so I'm not going to rewrite the entire formula again, but I'm going to use my guide right here to do it. So it's going to be P hat, which is 0.456. Oh, wait a second, I haven't found Z alpha over 2. Let's do that really quickly. So we're doing a 95% confidence level. So I come over here to my table. All confidence intervals are two-tail. So two-tail 95% is 1.96. That's all you do. Two-tail 95%, 1.96. So there we go. So following the formula, and I'm just going to be following this formula right here, so feel free to follow along if you'd like. So it's going to be 0.456 minus 1.96 times the square root of p hat, 0.45619, times q hat, which is 0.5438, divided by our sample size, which was 331, and it's the square root of that entire number, is less than p is less than 0.456 plus 1.96 times that gigantic square root again. 0.45619 times 0.5438 divided by 331. So there you go. That's how you would do your confidence interval. It's a lot of numbers, but hopefully you're able to follow along as I was writing them all out. So I'm going to go ahead and calculate the margin of error since that's the same number on both sides. So that's 1.96 times the square root of 0.45619 times 0.5438 divided by 331. Make sure that 331 is included in the square root. So that's my margin of error, so that's E, so that's a special number. I'm going to do 0.456 minus that number. Which gives me 0.402. And now I'm going to do that one more time. I'm going to do 0.456 plus my margin of error, that special number that we found. So 0.456 plus that number, which gives me 0.5096, which I'm going to round to 3 decimal places to 0.510. So there we go. And again, unfortunately, the answer that the book is looking for is 0.403. I'm really annoyed by that. I think it should still mark it as correct, but if it's not, you need to let me know so we can figure out how to get it right, okay? I do not know why they're so exacting, but hopefully they would count 0.402 as correct. There's your confidence interval. Based on this data, there's a 95% chance that this confidence interval contains the true proportion. And notice that 50% is in this confidence interval. So 50% is in this confidence interval. So let's answer the question about this. So I'm moving over to page 3. What do the results suggest about the ability of touch therapists to select the correct hand by sensing energy fields? Okay, so the key idea is that 50% is in our confidence interval, which means it's a candidate for the right answer. And remember that 50% is just as good as guessing. So if 50% is in our confidence interval, then that means you can be just as good at guessing as these touch therapists. So it says that there's not evidence to suggest that they can. It's not out of the question. We didn't disprove that they have the ability to sense metal, but the evidence suggests that you're just as good as guessing. So, which indicates that maybe that's what they're doing and they're not being totally truthful. So since the confidence interval is not entirely below 0.5, there appears to be evidence that touch therapists can select the correct hand. That's thrown out. It does contain 0.5. Since the confidence interval is not entirely above 0.5, there does not appear to be sufficient evidence that the touch therapists can select the correct hand. That is the correct answer. That's the whole idea. If the whole confidence interval was like 0.65 to 0.70, then that would be evidence that they have the ability to guess the correct hand. But since it contains 0.5, we're sunk. It's just as good as guessing. Since the lower confidence limit is below 0.5, there does not appear to be sufficient evidence. That's not right. We would need it to be above 0.5. Since the upper confidence level is above 0.5, there is evidence that they can select the correct hand. That's not true either. So hopefully all of this is making sense. We've gone through 3 examples. I'm going to go through one more example with you in the next video, and then I believe we will be on to the next section. All right, so I will see you in the next video. Let me know if you have any questions.